All right, so today we're going to work on solving two different types of exponential equations. So, by the way, this is homework 7-6. So we're just going to do the front page of it, by the way. But two different types. We're going to solve exponential equations, two different types of them. The first type is when there's an exponential on both sides of the equal sign. So I'm actually going to just do number one. So number one is 5 to the power of x minus 4 equals 25 to the power of x minus 6. Now basically what we want to do is we want to cancel out these bases. We want to cancel out the base. And so there's a couple ways to do this, but I mean, the main thing is, well, if I can get the base to be the same, which is actually something that we've already done, if I can get the base to be the same, then obviously, and they're still equal, then obviously the exponentials are going to be, or the exponents are going to be equal. What I mean by that is, well, obviously between 5 and 25, we would be able to recognize, oh, 25 is really just 5 squared. Just a reminder, this goes back to at the very beginning of this course, just a little reminder, if you have an exponent taken to the power of another exponent, what you can do is you can multiply the two exponents. So x squared to the third is x to the sixth. So just like here, well, this is 5 squared to the power of x minus 6, so I can multiply those two. So when I do multiply those two, I get 5 to the power of 2x minus 12, right? Now I've got now both my bases here are in fact the same. So now that they are in fact the same, I can just kind of say, all right, well, look, the bases must be the same. I can cancel them out. Another way of sort of thinking about this is what we're actually doing is I'm actually taking the log of both sides. I'm actually saying, well, log base 5 of this side equals log base 5 of this side. So what I do to one side, I have to do to the other, and it can stay equal to both sides, right? This is still an equation. Now, log base 5, well, log base 5, what is this asking? This is 5 to what power is 5 to the power of x minus 4? Well, I answered the question in the question. 5 to what power is 5 to the power of x minus 4? In other words, the log base 5 and the base 5 of the exponential cancel each other out, and so I'm just left with x minus 4 equals 2x minus 12. You don't really have to go through this step. It's pretty obvious that if I have 5 to the power of x minus 4 equals 5 to the power of 2x minus 12, you can immediately jump to x minus 4 equals 2x minus 12, but taking the log of both sides is another way of explaining that, right? So then let's continue on. Well, to solve this, I'm going to add 12. I'm going to subtract x. I'm going to subtract x. When I do both of those things, I'm going to get x on this side, and I am going to get 8 on this side. So that's number one. Let's do another one. Let's do number 4, which is 36 to the power of 5x plus 2, and that's going to equal 1 over 6 to the power of 11 minus x. The reason I really wanted to do this one is actually the base on both of these. I'm going to have to change both of them. 36 and 1 over 6, I understand that the connection between these is base 6. So if I do 6 squared, well, that's 36. And 1 is 1 over 6. Well, if you remember, negative exponents are a way to flip a fraction. So if I want to go from 6 to 1 over 6, I would actually just do 6 to the power of negative 1. And so 6 squared is 36, 6 to the power of negative 1 is 1/6. And now I can say, oh, well, my power to a power, I can multiply these. And so I get 6 to the power of 10x plus 4 equals 6 to the power of negative 11 plus x. Now I have the exact same base on both ends, and so I get 10x plus 4 equals negative 11 plus x. Again, now we're going to solve by subtracting x from both sides and subtracting 4 from both sides. This gives me 9x equals negative 15. To get rid of the 9, I'm going to divide both sides by 9. That clearly cancels out the 9. The x now equals, well, negative 15 and 9 are both divisible by 3. And so when I cancel out the 3 from the 15 and the 3 from the 9, I am getting negative 5/3. And so that will be my answer for number 4. Now, these are nice and easy to do by hand. However, oftentimes with exponentials, they're not possible to do by hand. And so let's continue on and do a couple that we can't do by hand. Namely, what if an exponential equals, is just hidden in an equation and we need to solve for a variable in the exponent position? For example, what if I gave you 10 to the power of 3x plus 4 equals 9. Well, just like any other problem, what you want to do is you want to isolate your variable, but our variable is inside of an exponential. So we actually are going to isolate just the exponent. Okay, so that's the exponential. 10 to the power of 3x, that's the exponential. So to isolate it, I am first going to subtract 4. When I subtract 4, I'm going to get 10 to the power of 3x, and that's going to equal 5. Now, once I've, so first I need to isolate the exponential. Okay, so first isolate the exponential. Then the next step I want to do is I actually want to turn it into something I can solve. Well, the opposite of an exponent is a log. So basically what I do is I'm going to change this into a logarithm. Now, what is a logarithm? So basically, I want to rewrite this as a log. Well, this is going to be log base 10, right? Base of the exponent is the base of my log, so log base 10 of 5 equals 3x. By the way, that's is generally an understood 10, so you don't even need to write it. So log 5 equals 3x is sufficient. Now, I want to actually solve this, but log 5 is not something I 10 to what power is 5? That's not something I can actually answer. So I'm going to go to my calculator and put in log 5. Now it's going to be a pretty ugly decimal, which is fine. But I'm not finished solving, obviously, because this is a 3x. So to get rid of the 3, I'm going to divide now by 3. And so I'm doing my log of 5 divided by 3. So I can either say, well, log of 5, close parentheses, then divide by 3. That works. Or I could have just hit divide by 3 and taken this decimal and divided it by 3. Either one is totally fine. So this is good. And so here's my answer for x. So x is going to equal, and I said go to 3 significant digits. That means, so 3 significant digits in this case is, well, it goes 2, 3, and then so the next digit here is going to be my next significant digit, which gets rounded up to a 3. So we're going to do 0.233 as my value of x. If we were really precise, we would actually do a wavy line here, because obviously x is not equal to 0.33, but we rounded it, so we're approximately 0.33, and so that's why we use our wavy line, or our wavy equal sign. Okay, let's do one more. This one I'm going to use an exponential with e. So what if I had 2 times e to the power of 3x minus 1 minus 5, and that's going to equal 73. Well, again, I first need to isolate the exponential, and then I need to rewrite, so I should actually have written that, rewrite as a log, okay? So first isolate, then rewrite as a log. So if I want to isolate my exponential, well, where's my exponential? Well, this is 2 times e to the power of 3x minus 1. So what's taking to the power of 3x minus 1? Just the e. So we actually just need to isolate that. So if I'm trying to isolate that, the first thing I want to do is I want to get rid of the 5. So I'm going to add 5 to both sides. That's going to give me a 78 over here, and a 2 times e to the power of 3x minus 1. All right, so again, I just need to isolate the, let's see here, sorry about that.